Right now, somewhere in your house, there is a tap. You have never once worried it might run dry forever. You turn a handle and water appears, cold, clean, endless. You do not think about it. You do not thank it. But 120,000 years ago, in the hottest deserts on Earth, a human being walked for 4 days under a sun that could kill in hours, with no water at all, and lived. The real answer for how is far stranger than willpower. You have probably heard that a person can only survive 3 days without water. That number is not wrong, exactly. It is just incomplete. It was measured in labs, in mild temperatures, on bodies with no training and no ancestral memory. Put a human in 120-degree heat, in open sun, with sand radiating heat back up into their legs, and 3 days should be generous. 4 days should be impossible. And yet it happened, again and again, for tens of thousands of years, across the driest places our species ever chose to live. So what actually happened inside those bodies? Start with sweat. You sweat right now, sitting still, reading this. It feels almost embarrassing, a design flaw, something deodorant exists to fix. But sweat is not a flaw. Sweat is one of the strangest and most powerful tools evolution ever built. Humans have somewhere between 2 and 4 million sweat glands covering nearly every inch of skin. No other large mammal on Earth comes close. A horse sweats. A few primates sweat a little. But nothing sweats like you. Harvard evolutionary biologist Daniel Lieberman has spent decades studying why. His research points to a brutal, elegant answer. Somewhere around 2 million years ago, on the open grasslands of East Africa, your ancestors lost most of their body hair and gained an enormous number of sweat glands, all so they could do one specific, terrifying thing: outrun everything else on the savanna. Not in speed, in heat. A cheetah can outrun a human easily over 100 meters. But a cheetah cannot dump heat fast enough to keep sprinting. It has to stop, pant, cool down, or it will cook its own brain. A human does not have that problem. You can walk, jog, walk again, for hours, in full sun, sweating the entire time, and your core temperature barely rises. This is called persistence hunting, and it is one of the strangest hunting strategies ever documented in nature. You do not catch the animal. You simply refuse to let it stop moving until its body fails before yours does. That single evolutionary trade, hair for sweat glands, is the first piece of the puzzle. But sweating that much should mean losing water fast. So how do you sweat for 4 days in the desert and not simply dry out? There is a second, quieter trade hiding inside the first one. Standing upright, on 2 legs, exposes far less surface area to direct overhead sun than moving on 4 legs ever could. At noon, when the sun sits almost straight overhead, a bipedal body casts a shadow smaller than its own footprint, while a 4-legged animal of similar size lies broadside to the heat, absorbing far more of it across its back. Your ancestors were not only built to sweat. They were built, quite literally, to stand thin against the sun. Even the shape of the human head plays a role most people never consider. A dense network of veins near the surface of the scalp and face allows blood returning from an overheated brain to be cooled by evaporating sweat before it circulates back inward, a kind of built-in radiator sitting just beneath the skin. Overheating the brain is catastrophic, faster and more dangerous than almost any other heat failure in the body. Evolution did not leave that risk to chance. This is where the story gets stranger. The San people of the Kalahari Desert, sometimes called Bushmen, have lived in one of the driest environments on the planet for tens of thousands of years. Anthropologist Louis Liebenberg spent years walking alongside sand trackers, documenting something modern science almost missed entirely. Persistence hunts in the Kalahari can stretch across an entire scorching afternoon, hunters moving at a steady, relentless pace behind an animal like a kudu or an eland, in heat that can exceed 100 degrees, often without drinking a single sip of water during the chase itself. How is that possible? Liebenberg's field observations describe hunts that can stretch across 20 or even 30 kilometers of open, shimmering heat. The hunter does not sprint. Sprinting would be suicide in that sun. Instead, the pace stays almost meditative, a steady jog broken by long stretches of fast walking, punctuated by moments where the tracker simply stops, crouches, and reads the ground like a page of text, deciding in seconds which direction the animal actually went. Every wasted step in that heat is a step closer to collapse. Precision, was never a luxury. It was survival math, solved in real time, with no calculator and no room for a wrong guess. Part of the answer is behavioral, not biological. Sand hunters do not fight the heat. They read it. They track in the cooler hours of morning. When they can, they use the terrain itself, angling their pursuit so the animal runs through thicker brush and rougher ground while the hunter stays on cleared paths. They know, with an intimacy modern people have almost completely lost, exactly which plants nearby hold water underground. This is the part almost nobody talks about. The desert your ancestors survived in was never actually empty of water. It was hiding it. The tsama melon, scattered across parts of the Kalahari, is over 90% water. A single melon can provide enough hydration to keep a person moving through a brutally hot day. Certain roots, buried deep enough to stay cool, store water pockets that trackers could locate by reading tiny surface cracks in the sand, cues invisible to an untrained eye. Ostrich eggs, hollowed out and refilled, were buried at intervals along known travel routes. Water caches planted months in advance for a future self, or a future stranger, to find. This was not luck. This was infrastructure. Water infrastructure with no pipes, no tanks, no visible trace at all, built entirely from memory, passed down for generations, encoded in stories told around fires about which hill hides which root. Here is the counterintuitive twist. The reason ancient humans could survive 4 days without obvious water was not that their bodies needed water less. It was that their knowledge of where water actually was ran far deeper than the ground itself. But knowledge alone does not explain the biology completely. Your body itself is doing something remarkable during dehydration that most people never learn about. In 2022, a massive international study led by researcher Yosuke Yamada measured water turnover, essentially how much water moves through the human body, across more than 5,000 people in 23 countries. Using a technique called doubly labeled water, scientists could track exactly how fast the body was using and losing fluid. What they found upended some old assumptions. Water needs are not fixed. They shift dramatically based on climate, activity, and something else, adaptation. Populations that live and work in hot, dry environments show physiological adjustments that people in temperate climates simply do not have. Blood volume regulation improves. The kidneys become more efficient at conserving water, pulling back on urine output almost automatically when fluid intake drops. Sweat itself becomes more concentrated, meaning the body loses less sodium per drop, preserving the delicate electrolyte balance that, if lost too fast, is often what actually kills a dehydrated person before pure water loss does. This is a critical detail. Dehydration rarely kills through thirst alone. It kills through electrolyte collapse, through blood pressure crashing, through the heart struggling to pump fluid that is no longer there. Bodies adapted to heat and scarcity buy themselves time by protecting that balance longer than an unadapted body ever could. Think about what that means. Somewhere in the deep evolutionary past, in a landscape that could not forgive mistakes, natural selection was quietly editing the human body for exactly this scenario. Efficient sweat, efficient kidneys, a brain wired to notice a slight color change in sand that might mean a hidden root. A culture built entirely around remembering. There is a second body of research worth sitting with here. Physiologist Michael Sawka, who spent much of his career studying heat stress for the United States Army Research Institute of Environmental Medicine, documented something soldiers already suspected but rarely had proven with hard numbers. Heat acclimatization is real, measurable, and shockingly fast. Within roughly 10 to 14 days of repeated heat exposure, the human body can increase its plasma volume, start sweating earlier, at a lower core temperature, and reduce the salt concentration lost through sweat by more than half. A body that struggled in the heat 2 weeks earlier can, without changing anything else, suddenly tolerate conditions that once felt lethal. Now imagine that process not happening over 2 weeks, but over an entire childhood. A body born in the desert, raised in the desert, exposed to that heat every single day from infancy onward, never starts from zero. It starts already adapted, already tuned. The way a body raised at high altitude develops a different relationship with thin air before it ever consciously notices anything is different at all. This is the piece modern comparisons almost always miss. When scientists once asked how long an untrained person could survive without water in extreme heat, they were quietly asking the wrong question. The right question was never about an average body in an average lab. It was about a body raised inside the very environment it eventually had to survive, tuned by 10,000 ordinary days long before the extraordinary one arrived. There is one more piece, and it might be the strangest of all. Psychologically, humans under extreme heat stress do something almost no other animal does. They pace themselves against a future they cannot yet see. A sand hunter tracking an animal for 6 hours in blistering heat is not simply enduring. They are calculating, constantly, how far to the next known water source, how much daylight remains, how the animal's own exhaustion is likely unfolding based on its tracks. This is not raw physical toughness. This is cognition doing survival's heaviest lifting. Researchers who study endurance athletes today have found something eerily similar, even without a single drop of desert sand nearby. The body, it turns out, often has more physical reserve left than the mind believes it does. Pacing, expectation, and mental modeling of the distance remaining change how the brain regulates effort long before the muscles actually fail. What ancient trackers were doing instinctively, modern sports science later rediscovered in a laboratory and gave a name to. The desert simply demanded the lesson be learned first, and demanded it be learned perfectly, because there was no second attempt if you were wrong. Modern researchers studying heat tolerance often separate physiology from psychology, as if they are two different systems. Ancient survival never allowed that separation. The body and the mind were solving the same problem together, in real time, with no margin for error. Consider, too, the sheer density of local knowledge this demanded. A sand elder was not simply tough. They were, in effect, a living, walking map of an entire ecosystem's hidden water sources, redrawn seasonally as rains shifted and old sources dried while new ones appeared elsewhere. Anthropological accounts describe elders being able to name dozens of distinct water locations across huge stretches of territory, each one tied to a specific plant, a specific soil color, a specific angle of shade, at a specific time of year. This was not folklore. This was applied, tested, life-saving science, refined across so many generations that by the time it reached any single person, it had already been quietly checked and rechecked by everyone who came before them. There's a modern echo of all this, that most people have actually seen without realizing what they were looking at. Every summer, a small group of endurance athletes attempts something called the Badwater 135, a foot race across Death Valley, one of the hottest places on the surface of the planet, in temperatures that regularly climb past 120 degrees on the asphalt itself. Sports physiologists who study these athletes describe adaptations that look almost identical to what anthropologists documented in the Kalahari decades earlier. Increased plasma volume, earlier sweat onset, a trained ability to keep moving at a controlled, almost boring pace, resisting the urge to push harder even when the body feels capable of more. Because pacing, not raw speed, is what actually gets a body across brutal heat alive. The difference is that these athletes train for this deliberately, for months, sometimes years, using heat chambers and saunas to force their bodies into acclimatization on a compressed timeline. Ancient desert populations never needed a chamber. The desert itself was the chamber, running every single day of every single life, generation after generation, until the adaptation stopped being something a person had to build, and simply became something a person was born partway into. There is one final layer to this story, and it might be the most overlooked one of all. None of this knowledge, the melons, the buried eggs, the cracked sand, the pacing, would have mattered if it lived and died with a single person. What actually kept humans alive across 4 impossible days was never one extraordinary individual. It was the fact that this knowledge got told. Around fires, in stories, in songs built specifically to be remembered. Water knowledge was compressed into a form the human brain is unusually good at holding onto: narrative. A story about the hill with the 3 cracked stones survives a human lifetime by simply being told to the next child sitting close enough to the fire to hear it. In a very real sense, storytelling itself was survival infrastructure, arguably as essential as any single physical adaptation covered so far. The San were not just physically prepared for scarcity, they were culturally engineered for it, in a way that let knowledge accumulate faster than any single mutation ever could. Now bring this back to you. You have never had to memorize which hill hides water. You have never had to read cracked sand for a hidden route. That knowledge, carried for thousands of generations, has almost entirely vanished from daily human life in less than 100 years, replaced by a tap you do not think twice about. And yet your body still carries the architecture built for that older world. The sweat glands are still there. The kidneys still know how to conserve. The instinct to notice subtle environmental cues is still buried somewhere in you, even if you now use it to notice which coffee shop has shorter lines instead of which valley holds a spring. Modern life has not made you weaker. It has made the skills invisible. Right now, if the water simply stopped, most people would panic within hours, not because their bodies could not endure longer, but because the knowledge layer, the tsama melons, the buried eggs, the cracked sand, is gone. The hardware survived. The software did not. There is something almost humbling in that. For most of human history, survival was never really about raw toughness alone. It was about knowing the land so intimately that scarcity itself became something you could quietly outmaneuver. 4 days without a drop in 120-degree heat was not a miracle. It was the final exam for a species that had spent 2 million years studying for it, one sweat gland, one buried melon, one remembered hill at a time. It is worth sitting, for a moment, with how quickly this all disappeared. 10,000 generations built and refined this system. It took less than 4 or 5 generations of modern infrastructure to make almost all of it unnecessary. A single century of pipes, pumps, and reservoirs, quietly retired knowledge that had taken 2 million years to construct. That is not a criticism of modern convenience. Nobody is arguing you should go relearn which roots hold water. It is simply worth noticing how strange that trade actually is, how much invisible engineering, biological and cultural both, sits underneath something as small as a glass of water from your kitchen sink. There is also a quieter warning folded inside this story. 1. The desert never let anyone forget for long. Knowledge that is not actively passed on disappears astonishingly fast. Some of the specific tracking and water location skills documented by researchers in the 20th century are already fading among younger generations who have moved toward settled village life and modern wells. What took millennia to build can be lost within a single lifetime of disuse. The body remembers its old architecture almost indefinitely. The mind and the culture built around it remembers only as long as someone keeps telling the story. Think, too, about what this means for how you understand your own limits. Most people today have never once been forced to discover what their body can actually endure, because modern life is engineered, quite deliberately, to make sure they never have to find out. That is not a flaw in you. It is simply a difference in the world you happen to occupy. The capacity built by 2 million years of heat, scarcity, and relentless walking has not vanished from your genome just because you have never needed to use it. It is closer to a language you technically still speak, fluently, somewhere in your cells, even though you have not spoken a single word of it out loud in your entire life. So tonight, when you turn that tap and water appears without a second thought, remember what that convenience actually replaced. Not weakness, not luck. A memory system carried across thousands of generations, written not in books, but in bodies built by the desert itself, in people who looked at the driest place on earth and quietly decided it would not be the thing that stopped them.